quiz. Like I said, I think today's lesson won't take so much time. I don't think it will take the full 1.5 hours. All right, we will see how it goes. But along the way, if you all have any questions, please remember to ask me to slow down, or you can ask questions as and when you want. Okay? Liling, okay, Ken? Liling, are you familiar with the topic of matter? Do you feel that you need a revision?
I don't know.
What do you mean you don't know? How long has teacher taught the topic already?
I think like 1 month.
Oh, so it's quite into the topic already, right? So you
Yeah.
know the properties of solid, liquid, and gas, whether or not they whether or not they have a definite shape, whether or not they have a definite volume, the basics, you know?
Yes.
You do? Okay, so I will jump into the MCQ direct. Along the way, you can mark yourself. I will also double check with you your answers for the MCQ. All right, Cheslin, are we ready?
Okay.
Okay, so everybody is ready. We will start, yeah? Okay. So, question 1. Liling, I just need you to type your answer into the chat group. All right?
Okay.
For each question, you just type automatically when I'm doing that question. Okay, so far from what I saw, I don't know about Liling's answer, but Shaslin's the only one who got this question wrong. So I will direct the question to Shaslin. Okay, everybody still must pay attention when I'm talking. Okay, so Shaslin, we have 2 beakers filled with water up to the 500 ml mark. So both beakers got 500 ml of water. One beaker is placed in the freezer. One beaker is placed in room temperature. Shaslin, understand? Now, I am going to put the beaker on a lever balance. So remember when I teach you about lever balance, it is this thing that tilts. Okay? This is a lever balance. Shaslin, understand? So I am going to put beaker X, the frozen one, on the left, and beaker Y on the right. This is the unfrozen one. So, Shaslin, when you see a lever balance or a beam balance, what is the question about? Is it about volume or is it about mass?
It's about
When I see an equipment like that, tilting one side, tilting the other side, is the question about volume or mass, Shaslin?
volume.
Lilin, do you hear my question?
Yes.
So, do you agree with Shaslin that this question is about volume or you think it's about mass?
Mass.
Brian, what do you think?
Mass.
Yes, Shaslin, when we have a beam balance or a digital scale, this question is always about mass. My dear Shaslin, can you please remember that? This question tells you nothing about volume, okay? So, Shaslin, what do you think you will observe? Will they be the same weight or will they be of different weight?
The same weight.
What do you think, Liling? Same weight or different weight?
Different weight.
Why Liling different weight?
Because the beaker X was placed in the freezer for 4 hours, meaning
So,
it will become a solid and it will become heavier than liquid.
who says that solid is heavier than liquid? Both are 500 ml.
Yes.
It is made up of the same amount of metal. It contains the same substance. No matter whether it's in solid state or liquid state, Liling, will the weight change?
No.
Exactly. So the answer is D. Okay? Shaslin and Liling, do you understand?
Yes.
Yes, Guy, what is your problem?
I put my answer in chat.
I know. Sky, I already saw all your MCQ questions. You didn't make any mistakes, so you don't need to tell me your answer, okay? Okay, moving on. Question 2. Question 2, I have quite a handful of y'all who made mistakes. Nak, Ryan, and Cheslin. Li Ling, answer for you, please. Okay, this question is about measuring volume. Okay, Li Ling, you also have made a mistake, so you must pay attention. So Nak, Li Ling, Brian, and Cheslin. The measuring cylinder is initially filled with 40 ml of oil. Okay, so initially, when I don't put all the balls in, it is 40 milliliters. Okay, and then now I drop in 100 balls. What is the volume of each iron ball? So how do I solve this question? Naksh. First and foremost, I must find the volume of what?
You must find the volume that increased from the 40 ml to
Okay,
what?
The change, is it? You are saying find the change in volume.
The change
okay?
in the volume.
So initially, it's only here. Before I drop in all these black color dots, it was only 40 ml. So what Naksh is saying is I need to find the difference. So what is the difference, Naksh?
The difference is 30 ml.
Okay, 30 ml, or as you can see here, it's also 30 cm cube. So, Cheslin, can you tell me, this 30 cm cube is the volume of what?
The volume of
The volume of what, dear? So initially, without the ball, it's 40. I put in the ball, it becomes 70. So this change in volume is the volume of what, Cheslin?
volume of the ball.
One ball or 100 balls?
100 ball.
Very good. So 100 balls, volume 30 cm cube. Brian, are you following? Ling, are you following? So question asks for one ball. So how do I find one ball, Brian?
30 divided by 100. 30
30
divided
cm cube divide by 100. Okay, I don't know whether you all learn division yet. Probably, right? When I divide by 100, look carefully how I divide. I see 0 here. I see 0 here. I cancel out. Okay, Naksh, can you mute? It's a bit noisy for the class. So 3 divide by 10. How do I solve 3 divide by 10? So 3 divide by 10, if you look, it is going to be smaller than 1. Okay, so all I need to do is I move the decimal place to the left by 1. So it's 0.3 cm cube. Can anybody not sure about the math behind this? Lilin, you understand? Naksh, you don't understand, is it?
I understand.
Okay, good. Cheslin, okay? You all learn decimals already? No, not yet. Haven't. Okay, so when I do 3 divide, anything divide by 10, right? Let's say 8 divide by 10. This is going to be smaller than 1. The answer is going to be smaller than 1. Okay, so number smaller than 1 is like 0.5, 0.6. These numbers are smaller than 1. So when I divide by 10, this 0, I move it as a decimal point forward. Okay, so it's 0.8. So in this case, 3 divided by 10, 0.3. All right, so answer is A. All right, can I move on to the next question? Sky, you okay?
Yes, you can
Sky,
move.
what school are you from? I never asked.
Fernvale Primary.
I'm from Fernvale Primary School.
Okay, can. Okay, question 3. Li-Ling, can I have your answer, please? If not, it is Naksh and Shaslin who made a mistake.
My
Okay.
answer for question 3 is B.
What? Li-Ling, what do you say?
My
Your answer is B, huh?
yes.
Okay, that's correct. Good. Okay, so Naksh and Shaslin, pay attention. Eugene filled a syringe with air and water. Okay. Syringe was sealed. And take note, Eugene could not push the plunger fully. Which of the following explains his observation? So air is gas, water is liquid. Now, Shaslin, do you think he could at least push the plunger a little bit or completely cannot push?
Can push in a little bit.
Why? Very good. So I can push little bit. Why?
Because it says that it cannot push in the plunger fully.
I know. Why? Why can I push it little bit? What is in the plunger that allows me to push it in slightly?
Air.
Very good. Now, Sky, can you explain to the class how come if there's air in the plunger can be pushed in slightly?
Because air can be compressed because air is gas. Gas has no depth fixed
No
volume.
definite volume. Thank you very much. Now, Brian, how come it cannot be pushed completely? What is the issue here?
Because air still occupies space.
I don't think so. What else is in the
Water.
syringe? Yes. So, my dear, water here has a definite volume, cannot be compressed. So why he can push slightly is because he can compress the air, but he cannot compress the water. Naksh, understand? So let's go through the options. Is A correct? Does A explain why he can push the plunger slightly? Naksh.
No.
Why? Mm.
Because we're talking about if it can be compressed or not. So if
But
air occupies space, it's not relevant.
okay, I kind of agree with you. So, okay, let's say we ignore A first. Okay, now I'm going to just highlight A. I park it one side first. Okay. So let's look at B. Does this experiment at all concern about water having a definite shape? Does having a definite shape affect its ability to be compressed? Naksh.
No.
No, right? Shaslin, do you agree? Whether or not water has a definite shape or no definite shape, it does not affect its ability to be compressed. Shaslin, correct? So statement B is out. So can we look at the options A, B, C, D, Shaslin and Naksh? Straight away, I can cross out A. Agree? Both of you? I can cross out C. I'm left with B and D. Okay? So Shaslin, does it tell me, this experiment, does it show that water has a definite volume? Yes or no?
No.
Does it? Why no? It cannot be pushed fully because water has a what? Shaslin.
Water has a volume.
Exactly. So is this statement correct?
Yes.
Huh? Yes. Okay. How about D? Can air be compressed fully, completely? Shaslin. Good. Air still occupies space. So it can